Hello, everybody, and welcome to another Microsoft Reactor stream today. My name is Erica. I am the program manager at the Reactor in Stockholm. Today, we welcome Alan Astor, who is tuning in from Israel. Hi, Alan. How are you?
Hi, Erica. How are you?
I'm very well, thank you.
Hi, everyone.
Yeah. Thank you for being with us. Here, giving us some good knowledge about Kubernetes, and you are here to represent Spot by NetApp, and you're a sales engineer. But maybe you can introduce yourself a little bit better, what you do as your daytime job before we actually go deep into the session and the presentation.
Sure. Thank you, Erica. So my name is Alan Astar, and I'm a sales engineer here at Spot by NetApp. Basically, we're helping our customers how to optimize the workloads in the cloud and how to run the workloads in the better way. And today we will talk about how we implement and optimize serverless and scalable Kubernetes in Azure.
Sounds great. Looking forward to that. Thank you very much. I'm going to put myself in the background. I'm going to be here listening and learning as we go. So just shout out to me, Alan, if you have any questions or anything happens. And guys watching, please feel free to ask any questions at any time throughout the session. I'm going to be helping Alan to monitor it, and I will just help him to read them up. So yeah, I see you soon. Have fun.
Thank you. So hi everyone again. So my agenda for today, we will start with the Autoscaling Kubernetes. We talk about the existing solutions of how to scale Kubernetes in the cloud today. We talked about the challenges that we have, like with Kubernetes and with the managing of Kubernetes in the cloud. We talked about our solution, Ocean. Ocean is our solution, Spot by NetApp solution, to help our customers to manage their workloads in the cloud. And today we will be focusing on AKS. And we finish with live demo of Ocean. So let's get into it. So I want to start with the Kubernetes architecture for everyone to be like on the same stage, on the same page. So Kubernetes has two main components. We have the control plane and we have the data plane. The control plane is where the master nodes runs and host all the management components like the etcd, API server, scheduler, etc. This part is managed by AKS, so basically we don't deal with it. The data plane is where the worker nodes run and hold all the pods and tasks. So basically, this side can scale from 0 to 1,000 instances, 1,000 worker nodes. So today, we will be focusing on the data plane, on the infrastructure. So Kubernetes has two levels of scaling. We have the underlying infrastructure level, and we have the application level, the pods level. So the pods level scale based on the application demands, and the infrastructure level scale based on the pods resource requests. So basically, both layers are interrelated. So today we will touch on both of them. So before we jump into the challenges that we have today, let's see which solutions are available today. So for the infrastructure layer, we have the cluster autoscaler. The cluster autoscaler is a component that helps us to adapt the number of the nodes into the cluster. So in brief, when the cluster autoscaler detects that we have pods in pending state or in unschedulable state, he will go ahead, launch a new instance, attach the instance to the cluster, and then the Kubernetes scheduler assign those pods into their new nodes. On the flip side, when the cluster autoscaler detects that we have an unutilized node, meaning node with 50% utilization and below, he will go ahead, reschedule the pods on another node and evict the instance from the cluster. So he basically do a kind of scale down. For the pod level, for the pods level, for the application level, we have two solutions. We have the horizontal and the vertical pod autoscaling. So the horizontal pod autoscaler, the HPA, is like looking for a specific metric, and based on that, he updates the number of the replicas, the number of the pods, basically to specify the application demands. So if, for example, we define kind of threshold for CPU or memory, and when we cross this, or when we hit this threshold, the HPA adjusts the number of the replicas accordingly. The vertical pod autoscaler, on the other hand, leaves the number of the replicas the same, but he increase or decrease the size of the pod. So basically, we need to rescheduling the pod again. So these are the solutions that are available today. By the way, these are a good solution, but keep in mind that Kubernetes was initially designed for the on-premises data centers, where you always have the capacity that you need 24/7, and you just need to assign pods to nodes, and that's all. By moving to the cloud, we change our model to a pay-as-you-go model, meaning we pay exactly for the resources that we consume. So now we need to make sure that our resources match the application demands as closely as possible, because we want to avoid over provisioning, right? We don't want to pay for capacity that we don't need. We want to eliminate the waste. On the other hand, we need to avoid from under provisioning as well, because we want to be sure that our cluster, we want that our application always have the capacity that they need. We don't want that application stuck because they don't have enough capacity. So with it in mind, let's see the challenges that we have today in the cloud. So the best challenge is to fit the best node to exactly to the next pod. Meaning, as you can see in here, we have a node pool. We create a node pool with 3 nodes, each node with 2 vCPUs, and 8 GB of RAM. Now we try to deploy a pod, but as you can see, the pod stuck in empty state. And this is because the nodes that we have can't meet the node demands or requires. So basically, now this pod will remain in pending state until we launch a bigger instance, a bigger node that can handling the requirements of the pod. The next challenge is WES. As you can see in here, the cluster efficiency is about 60 to 60% utilization. Very poor efficiency. Because, and by the way, this is something that we can see across all our customers. So basically, we can easily move those pods and deploy them on another nodes, and by that to evict this instance and reduce the cost by 25%. But because we don't hit the threshold of 50%, this instance remain live and running in the cluster. So this is like a really poor of efficiency. Let's go on to another scenario, another challenge. Spot instances. So as you all probably know, spot instances are cheaper up to 90% compared to on-demand instances. Furthermore, Kubernetes is a great fit and great use case for spot instances because they're both like ephemeral by nature. And this is why many customers trying to leverage spot instances on Kubernetes environments. But now, as you can see, we created a node pool with 4 spot instances. But now there is a customers that willing to pay the full price. So basically, all those pods, all those nodes can taken from us. And we can ended up with no capacity at all. So this is a challenge that we need to know how to overcome this challenge. So this is a big risk for us to stay without capacity. Lastly, I want to talk about the complexity and the administrative overhead. So as you know, each node pool can handle like a specific workload. So if, for example, I want to work with spot instances, I need to create a node pool that holds only spot instances. And by the way, a specific instance type as well. If I want that my application runs on on-demand instances, for example, I need to create a new node pool and define that the nodes will be only on-demand instances. And the same is like with GPU, for example. If I want to run GPU because I have like AI application, for example, I need to create another node pool and run only instances with GPUs. And as you can see, I can, ended up with many node pools. And this is something that really making like our life very like hard to manage our environment, our infrastructure. So let's talk a little bit about our approach, how we see the solution, or how we see the way that we need to run Kubernetes in the cloud. So our approach is that we need that the pods should define the infrastructure. We think that the pods are the first-class citizens. We don't need to tell them where to go, but they need to define by themselves the infrastructure. So if, for example, we have a pod, a small pod that we need to deploy, so we need to select automatically a small instance. And if, for example, we have a big pod, we want to launch and the autoscaler select automatically a bigger node. And if, for example, we have like big data, for example, big data application, and we need a pod with a GPU. So we wanted the autoscaler will select a node with GPU. And this is the same with on-demand. If we need like to run our instances or application on-demand instances because we can sustain interruptions, for example, we wanted the autoscaler automatically for us launch an on-demand instance and put the pods and assign the pods on this instance. So again, we think, or our approach is that the pods should define the infrastructure. Now I want to talk about what does it mean to run on serverless or nodeless experience. So basically, we drive towards no management or underlying infrastructure. We don't want you to deal with the infrastructure at all. We want you to deal with innovation, with deploy pods, with create the new pods, develop application, etc. You don't need to deal with the infrastructure at all. You just need to deploy pods, and we will take for the infrastructure. And we will launch the best instance for your pods, for your application. We want you to scale by request, meaning if now, for example, your pods scale out, we want that the underlying infrastructure will scale up as well, accordingly and correctly. Utility billing. We want you to pay only for what you use. We want you to eliminate waste. We really don't want you to, to over provisioning or to scale up a bunch of instances that your application doesn't need. Efficiency. We want you to work with efficiency. Fast scaling. Fast scaling could be scale down very fast. We don't want you to wait for a specific threshold for scaling out. If you can scale out even when your instances with 80% utilization, you should scale down. And you should do it fast because we want to save. We don't want you again to pay for what you don't need. And the same for scale out. If now you have peaks or spikes, we want you to scale out very, very fast because we don't want that your users, your applications experience any slowness. And eventually scale to zero. If you don't need to run your cluster right now, we want you to scale to zero. And we want you to provision the cluster automatically just when you need it. Automation. Now, I want to give some example why it's so important to choose the right instance. So, as you can see in here, we have 3 instances. This one, the first one, have 1 pod, and the pod requirement 6.5 gigabyte of RAM and 1.5 vCPUs. As you can see, we launched the D2AS version 4, and our instance memory is 8 gigabyte, and we have 2 vCPUs. As you can see, we have a pretty decent efficiency. The memory is around 81%, and the CPU is around 75%. And here you can see the cost per pod. The cost per pod here is 0.08. And by the way, this is the same as here, because here we have twice of the resources. We have 4 vCPUs, and we have 16 instance memory. And now we have the same pod scale out. And now we deploy 2 pods on this instance. So here the same. We have the same efficiency of the memory and the same efficiency of the CPU. And by the way, even the same price per pod. But now, if we need to scale up a little bit and we need 5 pods, instead to have D4S V3 for those 2 pods or another 3 D2AS version 4, we deploy a D8S V3. And as you can see, because we have the right decision regarding the pod, regarding the node, you can see that now the memory utilization is around 99%. And for the CPU is 94%. And by the way, we drop the cluster size by 20% just by choosing the right instance. And this is why it's so important to choose exactly the right type of instance. Now, I want to talk a little bit about our solution, about Ocean. Ocean is spot by NetApp solution to manage Kubernetes in the cloud. And today we'll be focusing on AKS. So as you can see, we have two layers of Ocean. We have the infrastructure layer and we have the application layer, the pods level layer. So now in the infrastructure layer, we manage all the infrastructure layer on your behalf. Automatically, you don't need to deal with anything. You just need to deal the pods and then to deploy the pods, and we'll take care for everything. So with our solution, in the same cluster, and even in the same node pool, we know how to manage on-demand instances together with spot instances. We know how to deal with various family types. So we can run like many family types on on-demand instances and spot instances together. We know how to manage your spot instances efficiently, the spot instances lifecycle. Meaning, if, for example, we have a node pool with 10 instances of spot instances, and if we see that, and if we predict, and we know to predict when one of the spot instances is about to terminate, we will automatically go ahead, add a new instance to the cluster, do like an health check, move the pods between the nodes, and evict the node that about to terminate. So as you can see, we always manage the life cycle of the nodes. It can be like with on-demand or with spot instances. Another feature that we have is like fell back to on-demand or fell over to on-demand. So in a scenario that we don't have like a spot instances at all, we can always fell over to on-demand instance, run our workloads, and when the spot instances will be available again, we will fall back to the spot instances as well. So as you can see, we can leverage spot instances, but with the confidence that you always have the capacity that you need. You will never go below your required capacity. Okay, and this is because we know how to manage your cluster, the spot instances. The second layer, this is the pod-driven autoscaling and the advanced binpacking. Meaning, as I mentioned before, when we detect that we have like unschedulable or pending state pods, our autoscaler fetch all the requests, all the requirements from those pods. For example, how much memory they need, how much CPU. Maybe they need to run on GPU. Maybe they have to run on demand. We take everything into account, and based on that, we will spin up the best instance in terms of price, in terms of size, and in terms of type. So basically, you just need to deploy your pods, and we will choose the best instance, the suit for these pods. You don't need to deal with that anymore. So basically, as you can see, we can, for example, run all those requirements, all those workloads at the same node pool. We call it like a VNG, a virtual node group, but for you, for now, it's like a node group. So you don't need. So basically, you can handling like with one node pool, and that's all. The second thing, this is like a binpacking. So as you can see in here, we are leveraging the binpacking algorithm. The binpacking is basically take a snapshot of the cluster every 10 seconds, and it's trying to understand or to calculate if we can move pods between nodes, and by that to evict one of the instances from the cluster. So if, for example, you have a cluster, or you have an instance with like 4 pods, and the binpacking can calculate that we can move those pods and spread them on another nodes, and by that to evict this instance from the cluster, we will do it. Of course, we take into account the constraints, the PDB, the pod affinity, node selector, etc. We take everything into account. But when we can, we will evict the instance from the cluster. And we don't care if the utilization is 50, 60, or 80%. If our cluster can handle those pods, we will do it. And this is why you will see that our nodes utilization is between like 85 to 99 to 95%. Very efficiently. Okay, and by the way, just with the binpacking, we can drop your cost by between 15 to 25%, just by pack the pods better on the nodes. Now, another feature that we have, very, very nice feature, is the cost analysis. Cost analysis, this is our tool to help you to show back or to charge back. So basically, we know how to break down your cluster per labels or per namespaces and show you each namespaces, for example, how much memory, compute, storage, and network they consume. And not like only by percentage, but also with the cost by dollar. So we can tell you, for example, the HR department of the operation department this month consume like 70% of the cluster, and the cost was like $2,000. You can generate reports, etc. But this is a really great tools to analysis, to cost analysis your cluster. Lastly, Terraform. We are Terraform partners. So everything that I will talk and will show you in the UI, you can do by Terraform. You can do everything by code. You don't need to deal with the UI at all. Okay, so basically everything can be done by code. That's all. So guys, if you have any question before we get into the demo, we have like a live demo for you. Okay, so can I jump to the demo?
Yes, you can.
Great. Okay, guys, can you see my screen? Yeah, can you see my screen?
Yes, yes, we can.
Okay, I take it like a yes. Okay, guys. So this is our spot dashboard. As you can see, we have like many solutions for the cloud. We have like the Elastic Group where we managing EC2 instances. We have Eco, we manage our commitments, our right saving plans for our customers. But today we will focus on Ocean, so which is the solution for us to manage Kubernetes in the cloud. So as you can see, we have like a cluster that I created before. So if I click on the cluster, we can see like many insights and information regarding our workloads. So here we can see, for example, the resources, how many the CPUs we are using, how much memory, if we have like a GPUs, how many running spots we have, the total savings that we generated. And by the way, the total savings is based on this is like because we are running on spot instances instead of on on-demand instances. And this is like to see the drop of the cost because we're using spot instances instead of on-demand instances. So I want to start with the nodes. Here you can see a list of the nodes that we have. So first, I want to show you the resource allocation. As you can see, the efficiency, the resource allocation of the cluster is very high. And this is because we are binpacking the pods. So as you can see, the CPU here, it's like 98, like very efficient way, 100% CPU, etc. By the way, right now I have only one VNG. VNG is like a node pool. So here you can see the life cycle. So as you can see, the same VNG, I can mix between spot instances and on-demand instances. Okay? And another thing, this is the VM size. So in the same cluster, in the same virtual node group, I can use many types of VMs, many sizes, like standard T4 A5, AS V5, and D4 AS V5, and D2A V5, V4. So as you can see, many instance types at the same cluster, at the same node pool. Another thing, this is the availability zone. As you can see, we know how to spread the pods across the availability zones for high availability. By the way, we can control it as well. We can say, for example, where we want the pods will run, but in most cases, we prefer to spread it for high availability. Okay, another thing that I want to show you is this. If we go here to customize scaling, you can see that we can control a couple of things. One, the autoscaling. We can adjust the autoscaling and define how much instances we want to reduce or to scale down in any scale down cycle. So if, for example, we have 10 instances in the cluster and we see that we can scale down, and we have a scale down cycle right now, so if we change it to 10, for example, so we scale down only one instance per cycle. Okay, if we change it, for example, to 50, so we can scale down 5 instances in any cycle. And this is basically depends on your application, because if you have many pods that come up and come down and afterwards come up, so we can play with it. So we don't want to play or to scale down too aggressively. Okay, we want to keep resources. So we can like adjust the scale down ratio based on our applications. Another feature is automatic headroom. Automatic headroom, this is something that we can define at the cluster level or at the VNG level. I always like, I'm right to go to the VNG as well, but here you can define how much spare capacity you want to leave for 2 things, by the way. The headroom is good for 2 use cases. One is for spikes, because if you know that you have like very heavily spikes, you want to leave like a capacity that can handling these spikes. You want to avoid the slowness of the application. Second, we are working with spot instances, mainly with spot instances, and we will always like experience interruptions. So we want to, that if we have like any interruptions, we want to recover very fast. We don't want to wait each time that we have like a pod interruptions or spot interruptions. We don't want to wait for a new instance to scale up. Okay. By the way, we can play with it. We can schedule the headroom as well. So we can say, for example, that on our rush hours, when we have like spikes in the morning or in the evening, that the headroom will be like 20%. And after the work hours or in the night, it will be like 0. So we can play with it. Another great feature that we have, this is the cluster shutdown hours. With the cluster shutdown hours, we can adjust the cluster and decide when we want that the cluster will run. So basically, we can say that we want that our cluster will run only from Monday to Friday between 8 a.m. to 8 p.m. And out of those hours, the cluster we provision and we scale down the cluster to 0. And in the morning, we will provision the cluster from scratch. So basically here, you have 2 advantages. One, you pay only for when your cluster runs. This is one. And second, each morning, we will provision a new spot instances for you. So basically, the chance that you have, like, or you experience any interruptions, spot interruptions, is very low. So this is for cluster shutdown hours. For the node pools for us, or virtual node groups, for us, it's like a node pool. Okay, right now, I have only one node pool, but basically we can define as much as node pool that we want. So now we have only one that's called prod. So for example, you can say that you want to create another node group, call it, for example, dev, and run all your dev environment. Or you can, for example, play with the ratio of the life cycle of the instances. So maybe you can say, okay, so I have a front end, so I want to run those VNG, I want to run only with spot instances because it's stateless. And basically, if you have like, I don't know, databases or master node pods that you don't want them to interrupt, and you want them to run on on-demand instances, so you can create a VNG and define that specifically this VNG will run only with on-demand instances. So if we click on the virtual node group, if you can see things that you can adjust. So we have the labels that you can define, for example, we have the tails, we have tags, we can define minimum and maximum nodes, the strategy percentage, meaning you want to run like 100% spots, you want to run 50% spots and all the rest, and 50% on demand. You want to fall back to on demand, maybe you don't want it if it's like, I don't know, a cluster like staging cluster or staging environment, you don't want to fall back to on demand, so you can define that well. So the availability zones. So as you can see, each VNG has its own characterism. Here again, you can see the pods. And as I told you, every time or each time that we're trying to deploy pods, the autoscaler, the Ocean autoscaler, takes the decision what is the best instance. So here you can see that every instance that we launch, that Ocean launch, we give him like a stamp. If this is like an on-demand instance or spot instance. So as you can see here, we have the life cycle. So the life cycle of this instance is spot. If it was like an on-demand, the life cycle was OD. So now, because this is like a spot instance, we will provision only spot instances or spot or pods that want to run on spot instances. If it was like a OD on demand, so we just need to label our pods with this value, okay, like an on D, and that's all. We will deploy those pods automatically. We will spin up on-demand instance. So we don't need to deal with it a lot at all. Sorry. Any questions about our platform?
No questions so far.
Okay, so basically we can define a headroom based on the units as well. So we can say, for example, that we want that our virtual node group at any point in time, we'd had like 2 spare instances. Okay, so if we have like a spike, we always have enough resources to run on. So I want to do like kind of some of a demo to see how our platform know what kind of instance to spin out. So if you go to the nodes, we can see that now we have like lifecycle 2 on demands. Let me see if I can share. Okay, here. Now I go. Okay, so I can share my. Okay, just a second. Okay, so I can share my video code. So believe me that now I'm running 2 replicas on on-demand instances. So go to the on-demand and I run a pod that required or request for on-demand instance.
Alan, I think we lost
Yeah.
your screen. I added it back, but now it's I don't know if it's the right one.
Okay, just a second.
Okay,
Now?
now I see it moving. So yeah, I think it should be. You are now. Your mouse is virtual node groups, right?
Yeah.
Yeah. Okay, then we
Which I
know
know
it.
because basically because I can share my my Visual Studio. So
Ah,
I wanted
yes.
to show how I like deploy a new pod.
Yeah, but
So
you're all good now. Thanks.
okay. So now I running a new pod. I'm asking for a new instance because I'm running a pod that requests for on-demand instance. So let me see, it is running. And now I'll try to run another 2 big replicas of spot instances. So I take this, just a second. Okay, so I run the command, and as you can see in here, we have a scale up node in progress. So if you go to the nodes, we can see that, again, we have one VNG, and at the same VNG, we have multiple kind of workload of instances. So right now, we have our autoscaler detects that we have pods in pending state. Basically, we don't enough space on our on-demand. So on-demand instance, so we deploy another node. So to take like 2 or 3 minutes, like with AWS, like with the AKS. So if you have any more questions, guys, until the pods or until the nodes will be ready, it will be great. I talked a lot, so no questions at all.
Yeah, actually, we have. How much time does it take to start working?
To start working with our platform.
Yes, I believe.
So basically, it's very, very fast because basically you just need to connect to our account, to our website. To connect, this is like a SaaS solution. So you just need to sign up, connect your accounts to your subscription, and from there it's like 10 minutes, and we can import or create a new instance, a new clusters, and start working. So if you can see my screen, I have like you can see my screen.
Yes, we can see your screen.
Okay, so as you can see, this is a straightforward process how to connect the existing AKS cluster. So basically, it's very, very easy. Just you need to connect to deploy our controller on your cluster. We fetch all the metadata automatically to our system. You don't need to define nothing from your end, and we can like up and running.
Thank
Very,
you.
very easy. Yeah.
And then the question, is there a free trial? And what can we do with it out of all the things you showed in the free trial, if there is any?
Okay, so in the free trial, we give you like the ability to run up to 20 instances. So basically, you can define the cluster, you can create a cluster, and define or to run up to 20 instances. So it will be better to do it with our help, with our solutions architects. We can extend or increase the size or the number of the instances, but by default, it's like 20 instances in a cluster.
Thank you.
By the way, the scale up is finished. So as you can see now, we have like 3 on-demand instances and more spot instances. So the scale up works very, very fast. Any more questions, guys?
Yes, there was one more. Can this be managed via CLI and not a UI? With what tools then, if it's possible?
Yeah. By the way, you can manage it from with any infrastructure tool that you have, like from as I mentioned, with Terraform, for example. Because by the way, we're just replacing the autoscaler. Okay, so basically you can continue to work with the same tools that you have today, and to create a cluster, etc. And we will take care for all the rest. So basically, yes, Terraform and any like infrastructure as a ISC tools, infrastructure as a code.
Thank you. We have another question here. How do you define workload pod requirements for insurance, spot, on demand, disk performance, etc., etc.?
Okay, so we have a labels. Okay, so each pod we can label with if the life cycle is on demand or spot. So by default, each pod we will deploy like as a spot instance. But if, for example, we need to run specifically this pod with an on-demand instance, we just to add like in here, if you can see, not on demand. So as you can see in here, we just need to add this label in the node selector or in the node affinity. And when the Ocean autoscaler will detect this node selector, he will spin up automatically an on-demand instance, and that's all. By default, it will be like a spot instance. And if you need to run a GPU, for example, for a specific GPU, we just need to add the same, like a label of GPU, even with a specific GPU that you want, and we will spin up an instance with a GPU. So by default, it will be a spot. For on-demand and GPU, we need just to add another label, and that's all, very easy. So again, you don't need to deal with the node pool. You don't need to deal with the virtual node group, nothing. You just need to label your pods, and that's all. We will bring the best instance for you.
Thank you. I don't see any questions anywhere now. So yeah, audience, if you have any questions, ask them now, because I think we are going to come shortly to the end of this session. Oh, there is another one from Gregos. Could you explain how you handle spot instance termination once again, please?
Yeah. So basically, we have our algorithms to predict when a spot instance is about to terminate. By default, from AKS, it's like up to 30 seconds. With our solution, it can be like up to 1 hour. But when we run into a node group and we detect that and we predict that one of the instances is about to terminate, so we first spin up a new instance, attach the instance to the cluster, do like a health check, and when we see that the instance is up and running, we reschedule the pods from the old instance to the new instance and evict the old instance for the cluster. So this is like a classic scenario for us. This is how we manage the life cycle of the spot instances. But again, if we don't have a spot instance at all, we will automatically fail over to on-demand instances. And when one of the spot instances become healthy or become available, we will fall back to spot instance as well. Again, by the way, when we manage the node pools or the virtual node group, we choose out of something around out of 100 or 80 different instances, not 1, 2, or 3. So we will always can find like spot instances, like a free spot instances, or this is how we can like choose the best instance for these specific workloads. Okay, we don't like define 2, 3 instances and try to choose the best node from them. We find the best node based on hundreds of instances. But this is how we manage the life cycle of the spot instances. We predict the interruptions and replace between the nodes. By the way, with our headroom, we keep enough space that if we see that we have like if we like have interruptions, so sometimes we can rescheduling the pods even without like put them into a pending state. We just move the pods between the nodes because we have the headroom. So it's very quick, very fast.
Thank you. There are no more questions for now.
Okay, so thank you very much. Thank you, guys. So if you have any questions, if you want to, a dedicated demo, something like if you want to start a POC, if I can share my scan. Okay, this my slides. Okay, so I can. So feel free to reach out with any questions, POC, demos. I will be happy to jump on any call, guys.
Thank you so much, Alan.
Thank you. Thank you.
Also says thanks, Alan. It was great. So yeah, I hope to see you once again, maybe sometime soon at the Reactor stream. And I wish you to have a great day. And
thank you.
Thank you so much.
Thank you. Bye-bye, everyone. Bye.
Bye.